Hi guys, welcome back to school. This is Mrs. Clark here, and this is your very first note-taking guide that you're going to do in order to just kind of figure out the way that my videos work and how to use this website. So if you'll please follow along with me, I'm going to work all 12 problems for you. You just need to follow along, fill it out exactly the way that I do on your note-taking guide, and then when you're done, bring it on up to me and I'd be happy to give you your points on it. So we're going to just start with number 1 and we'll work through to number 12. So number 1 right here asks us to graph the ordered pairs. If you remember, when we're graphing ordered pairs, we always go X and then Y's. So we need to look along the X axis first, which is left and right, and then we need to look at the Y axis, which is up and down. So I need to go to -4 on the X axis, which would be to the left, to -4, which would be right here. But my point doesn't get to be right there. I actually am going to move that point up 2 on Y. So over -4 and up 2 gives me a point right here. That point would be called point A. So just graph that for me. We're going to go and we're going to do these other ones. I'm going to go a little bit quicker, so we're remembering that we're going X and then Y. So on the X axis, you're going left and right 0, and then you're going up 6. So your ordered pair should be right here, 0, 6, and that would be ordered pair B. The next one is 5, 0. So we're going left and right 5 and up 0. So the ordered pair is going to be right here. That's ordered pair C. And then our last ordered pair is 0, -3. So we go left and right 0, and then we go down 3. So our ordered pair is right here, and that's the ordered pair called letter D. So again, just the important thing to remember on graphing our ordered pairs is that we always do our X's first, which is left and right, and then our Y's, which is up and down. All right, let's move on to our second problem and take a look at it. This one says solve the equation for X. When we're going to solve the equation for X, I like to use what we call the cover up method, where I like to just look at this part, kind of cover it up, pretend like it's not there, and see what I need to move. I would need to move that plus 12 to the other side of the equal sign. And how do I get rid of a plus 12? I do the opposite, which is subtract 12. So I'm going to subtract that 12 to the other side and go from there. So minus the 12 to the other side. If you do it to one side of the equal sign, you have to do it to the other side. So over here I have this 2x that's going to be brought down. And then on the other side I have 38 minus 12, which is 26. Then from there, I would use that cover up method. So I would look at this and cover up the x, which means I need to get rid of the 2. The 2 is multiplied by the x, so how do I get rid of multiply by x? I do the opposite, which is divide, what do I do to get rid of multiply by 2? I do the opposite, which is divide by 2. Sorry about that, I said x instead of 2 just right then. Those are going to cancel because 2 divided by 2 is 1, and over here I have 26 divided by 2, which happens to be 13. So that's number 2. Next question asks us to do the same kind of thing. We're solving this equation, but this time we're solving it for letter Y. Now this is a little bit different because if you look at this equation, I have some Y's here and I have some Y's here. The very first thing that I want to do when I'm solving an equation that has more than one variable in it is I want to get the variables on one side together. So I need to decide if I'm moving these ones over here or if I'm going to move the 2y over to the other side. Now, I always like to move stuff so that they can stay positive. So if you see this is a -3 right here, in order to get rid of it, I can add it to the other side. So I'm going to add it to the other side. That's just the way that I choose to do it to try and keep things positive. So I'm going to add the 3y over to the other side. It cancels over here. That's why I did it in the first place. And I'm left with that -15. On this side, I have 2y plus 3y, which is 5y, and I still have plus 45. So if I use that cover up method now and I just kind of cover this 5y up so it's not there anymore, I'd have to get rid of that 45. The 45 is added to this side, so in order to get rid of it, I'm going to subtract the 45 to the other side. So it cancels over here like it was supposed to, and I get 5y. And on this side I have a negative 15 and a negative 45, which adds together to be a negative 60. So I would have negative 60 on this side. Then again, cover up that y and see what you need to move. You need to move the 5. The 5 is multiplied by the 5, so I have to do the opposite, which is divide by it. So I'm going to divide both sides by 5. And when I do that, I do negative 60 divided by 5, and my answer is negative 12. So a negative 12 is equal to y. That's my solution for this particular problem. All right, let's take a look at number 4. Number 4 says, is the ordered pair 7, 5 a solution to the equation? If you notice on this equation right here, I have a y value and I have an x value. Well, guess what I have up here? I have an x value and I have a y value. So really all this problem is asking me to do is substitute those numbers into the equation. So my y value is 5. My x value is 7, and then I still have minus 9. So I took that 7 and I put it in place of the x. I put that 5 in place of the y. Now I just need to simplify it. So 2 times 7 is 14. So on this side I have 14 minus 9, which happens to be 5. So 5 equals 5. Because this is a true statement, my answer is yes, it is a solution. If it was a false statement, my answer would be no, it is not a solution. All right, let's head on to number 5. This one says find the slope of the line. Now this is quite simple if you remember slope y-intercept form of the line. That's y equals mx plus b. M actually stands for the slope of the line, and b actually stands for the y-intercept of the line. So all you have to do is check to make sure that this equation is in the right form and then find the slope. That equation is in the right form, so I need to find the slope. The slope is attached to the x, and so my slope is equal to 2. The slope is represented by the letter m. All right, let's head on to the next problem, number 6. This one says find the y-intercept of the line. So again, back to what I just said, if we're looking at an equation in this form right here, this back part, the b value that's added or subtracted on, is the y-intercept. So I need to get my equation into that form. Now if you notice here, my y is over here, and I need y to be equal to everything else. This y has the plus 2 over here, so I have to move it over to the other side. To move a plus 2 to the other side of the equal sign, I'm going to have to subtract it. So it cancels over here to just give me y. And then I have a negative 2x, and then a negative 4 and a negative 2 make a negative 6. So this is just kind of flipped around. I could actually write the y out front. It would still be equal to 2x minus 6. And then I can easily see which one is my y-intercept. I'm actually going to keep my sign on that, so my y-intercept is actually the number negative 6. All right, next problem, number 7. This one says graph the line, and I gave you y equals 3x plus 1. Now again, using the information that we just went over, this number back here is the y-intercept. It's where my graph touches the y-axis. This number right here, the 3, is my slope. The slope is my rise over my run. Rise is how far up and down I go. Run is how far I go to the right. So my y-intercept tells me where to start my graph. It tells me to start up at 1 on the y-axis. So my y-intercept's right there. My slope tells me how far to rise and how far to run. If it's not a fraction, I'm going to make it a fraction. The number 3 becomes a fraction by being the number 3 over 1, and then I'm just going to follow my rise, which is up 3, so 1, 2, 3, and over 1. Up 3, over 1, up 3, over 1, and my line goes through those ordered pairs. I didn't do a very good job getting my line through those ordered pairs, but just do the best you can. All right, that was a bell on the recording. Darn it, class is not over yet. Okay, let's go on to number 8. We're going to graph this line. It's not in the right form in order for us to do it the way that we just did, but there is another way for me to do it when it's in this form that might be a little bit easier. If we found the x and the y intercepts, where my graph crosses or touches the x-axis and where it crosses or touches the y-axis, it will be a lot easier. So picture this problem right here, right now, like that x wasn't there. Let's say we make that x equal to 0. Could we easily solve for what y would have to be? -4 times the number equals 12. Well, that number that y would have to be would be a -3, because a -3 times a -4 equals a positive 12. So we can totally do that. That would be called the y-intercept because it's our y equals. And then we can do the same thing for the x. So this time, make all the y part disappear and solve the equation 2x equals 12. Well, 2x equals 12. What does x have to be? 2 times a number equals 12. That number has to be x equals 6. So you can totally solve this one by doing what we call find the x and the y intercepts, the way we just did. You could have also solved it for y and then did the slope and the y-intercept. But here, if my y is -3, then I go on the y-axis to -3, and I'll have a point right there. Here my x is 6, so I go on my x-axis to 6, and my point is there. And my line goes through those two ordered pairs. That's how we can graph a line when it's not in y equals mx plus b form. All right, this line looks exactly like one of those x-intercepts and y-intercepts that we just did, but this is actually a line. So the line is x equals -3. So I'm going to go on the x-axis to -3. And then I have to decide, well, my x would be -3 all the way up here and all the way down here, which means my line's going to be this vertical line that goes through x equals -3. Same kind of a thing on the next one, but this time it's a y equals line. So it says y equals 5. Well, y equals 5 here. This would be the ordered pair 3, 5, so y is 5 there. This would be the ordered pair 8, 5. And my y's equal 5 all along that line right there. So my line that I'm graphing for y equals 5 is that horizontal line up at 5 on the y-axis. All right, 2 more problems. We're almost there. Number 11, find the slope between the 2 points. So we have a slope formula. The slope formula is slope equals y2 minus y1 over x2 minus x1. So where does that formula come from? Well, it comes from our ordered pairs. This would be x in my first ordered pair, y in my first ordered pair, x in my second ordered pair, y in my second ordered pair. And I would just substitute those into my formula. So y2 would be 10 minus y1, which is 6. x2 is -5, and x1 is 4. Then I just simply do the math and reduce the fraction. 10 minus 6 is 4. -4 minus 4 is a -9. So that doesn't actually reduce. My slope is a -4 over 9. So this formula right here is really easy to use if I want to find the slope. I also could have just graphed those ordered pairs and found the rise over the run in between the 2 points. That could have also worked depending on where those ordered pairs were at. Okay, last problem here says find the x and the y intercepts. Now I already showed you how to do that once. to graph something. Let's just pretend like this x is gone. We make it a big fat 0 there. Can we solve this equation now? 9 times the number y equals 27. What does y have to be? Y has to be the number 3, because 3 times 9 is 27. Then let's do it the opposite way, and this time let's pretend like the y's aren't there. So 3 times a number equals 27. What does the number x have to be? It would have to be the number 9. So here's my x-intercept. It's an x equals number. Here's my y-intercept. It's a y equals number. And again, the way that I find that is by setting the opposite part equal to 0. So when I got my x-intercept, it's because I set y equal to 0. When I got my y-intercept, it's because I set the x part equal to 0. You guys, thanks for listening to me. Please bring this paper up to my desk. Let me give you credit for that. And please make sure you mark this website as one of your favorites on your favorite bar. That way you don't ever have to input the long website name again, and you can just click on it when you miss a day of class to listen to the note-taking guide. Thanks, guys.